So this talk is a talk I wrote. It's about event-driven automation. And when I originally wrote this, my intention was to just kind of do crazy things that you could do with Salt. A lot of this you do not want to do in production, so please do not do this in production. But I just wanted you to see, kind of open your view of what Salt can do. So I'm going to go over some of the real basics of Salt really quickly, but I'm going to assume everybody in the room at least has a medium, level of understanding of Salt. So early on, when we first started Salt, SaltStack, the company, there were 4 engineers, and so I got roped into doing professional services and trainings and consulting with different customers, and I'd never done professional services before, and so it was kind of freaked me out. I'd sit down with these big companies that I've used their software for years, and they're like, okay, we have this big custom database, this and that, we want Salt to automate it, can we do that? And I'd never even seen some of these tools that they were using, and especially not at the scale that they were doing things. And so I took a deep breath. I thought, well, I know Salt. I'm an expert at Salt. And so I talked to the engineer, and I was like, well, okay, you're the expert on your software. I'm an expert on Salt. Let's work together and make this happen. And so, approaching it from that perspective, we were able to go out and build everything that everybody needed. And quickly came to realize the way Salt's built, you can pretty much make Salt work exactly how you need it on your infrastructure. So Salt comes with a whole plethora of modules and functions and things that are available that SaltStack, the company, our engineers have built, and even hundreds more that members of our community, I'm sure many of you have committed pull requests to add features. And so there's a ton of things that come with Salt that we can leverage. But you always, if you're at any kind of scale or any kind of uniqueness in your company, which most people are, you will hit a situation where there isn't an out-of-the-box solution. And Salt makes it very easy for you to plug in what your custom code that you need for your infrastructure. Even if you don't know any Python at all, you can even take your current bash scripts and have Salt run those for you. We've taken people's bash scripts that take up over 35 minutes to run, and by parallelizing it and converting those to Salt states, took just over 3 minutes to run. So we can make Salt do what you want to do. All right, so in Salt basics, right? You have a Salt master. Typically, you have a Salt master and a Salt minion. They connect usually over ZRMQ, or you can use a TCP transport. We also have Salt SSH that allows you to connect to servers over SSH. So that's like kind of an agentless scenario. And then you can also have the minion run in a standalone mode, so there is no master. So that minion has all of the information and resources it needs to configure itself. A lot of times I do that with my laptop. I can get a new laptop, plug in my Salt states, install my laptop, get it set up how I want ahead of time. So here's a kind of little diagram, right? Most of you are probably familiar with that. So the bottom 2 minions there are connecting over the normal standard ZRMQ connection. Then we have a Salt SSH minion that we're connecting. The cool thing about Salt SSH is basically almost everything you can do over the regular ZRMQ minion, you can do with a Salt SSH minion. And if you're an enterprise customer as well on Windows as well. I think the only thing that doesn't work is the event bus, some things like that. So some advanced topics are, like I mentioned, we have the event bus, we have beacons, reactors, and Salt API. There's a lot more, but these are some of the first things that people get into when they get beyond just configuration management. There, I'll plug that back in a minute. So in our diagram here, our minions that are connecting over ZeroMQ, or if they're connecting over TCP, have an event bus that they share with the Salt master. So there are a variety of events that are occurring on the minions, and those get sent up to the master, so the master can see what's going on. So some events that you can see on the Salt master are things like a minion when it starts up. When a minion finishes running commands, you'll see events come through. You'll see when a high state is run. You can also send your own custom events. So you could have Jenkins running on the minion, and then Jenkins could send an event that goes up to the Salt master, and you can see what's going on. So this gives you like a live view of things that are happening, both Salt events and your own custom events. Your own applications can send events. It's a really powerful tool for seeing what's going on. Now, once we have those, in addition to the Salt events and your own custom events, we have a thing called a beacon. A beacon typically runs on a minion, and a beacon watches something live on your minion and sends events when that thing changes. So, for example, there's an iNotify beacon, and whenever you can specify a file or a directory structure, if any changes occur, it'll send an event stating that there was a modification to a file or change. There's a service event. You can watch a service and send a notification a service has gone down or changed status. There's a whole variety of them there. I lose track of how many we have. And they're also really easy to write. So if you have a custom application and you want a beacon to kind of watch that application or something, then you can write your own. Like most of the beacons are like 40 lines of actual code, if that, 20 lines of actual code. So it's a really powerful way to get information from your minions back up to your masters. Now, once we have that flow of information, we want to do something with that. And that's where reactors come in. And then it will run reactor states, which are essentially salt states of any kind, to do something when that event happens. So, for example, I had a customer once that had this proprietary application they had purchased, and the service would just die every once in a while, and they knew it, and the solution was to have the sysadmin go in, restart it, and they're waiting for a fix, which was months down the road from their vendor. So instead of having to have their sysadmin go in and fix it every time, they would watch that service. When the master would see that event, the reactor would then run a command on the minion saying, hey, restart that service, and notify in a log in their CMDB that happened. So it's kind of a distributed supervisor D kind of watching a service. Another one had a directory with assets that designers would copy updated images and things into. So they would watch that directory when new images got dumped into that directory, and would see those images, then it would run a salt state on the master that would then copy those images to a variety of other servers in their CDN to automate getting those files pushed out. So really, anything Salt can do, a reactor can do. And so sky's pretty much the limit there. And then Salt APIs are really, you have the ability to turn on a REST API that you can create users and set up, give them authorization to run certain commands. And you have the REST API to use Salt from your own applications. So we have users that have a CMDB, they change like a host name for a computer. Once they hit save, that reaches out to the Salt API, runs a Salt command to update the host name, or some other configuration. If you have, you could have Jenkins reach out to Salt, run things. ServiceNow can reach out, touch the Salt's REST API, run commands. Really, again, the sky's the limit. And it's amazing the things that people build with this whole bare metal infrastructure workflows from, they unbox it, rack it, turn it on, and a whole automatic workflow from imaging the server all the way to configuration on a development network, and then testing it, and then transitioning to a production network, registering on production, all using beacons, reactors, and Salt's REST API to integrate with other things. So people are using this with all the new hot Kubernetes Docker stuff and integrating it in with their old Cold Fusion server that they've been using for 15 years and is not going away. I mean, Salt can reach out and touch pretty much anything that you can throw at it, and you can add stuff to it. So here again, I'm just describing, we have beacons and engines run. Actually, I think that's wrong. Engines run on the Salt master usually. Beacons and events send that information to the master, and then you can control those things from your Salt master.
How is an engine different than a reactor?
An engine, so reactor is, so the question was, how is an engine different from a reactor? Great question. So a reactor, maybe I should show you some examples of the, I'll show you some examples of the configs. Trying to clone my screen here real quick. Okay. So in our master config, so here, this is kind of jumping into my demo a little bit, but here we're specifying reactors we want to set. Is that large enough to see? It's okay, a little bigger. So here we're specifying that we want to watch for, on any minion, for an iNotify beacon event, and specifically for this file that sits in /serve blah.txt. And when that beacon gets run, we're going to run this SLS file and this reset configs SLS file. So those are basically salt states that do something when that event comes through. An engine allows you to, it's a long-running process that you can do things in a more programmatic way. So it's these reactors in the event bus are very ephemeral. So they come through, they process it, and they're done. Whereas an engine allows you to have this long-running process that you can keep tallies of information. I actually haven't used engines a whole lot. We have several that we use within Salt to manage several different things. But
Basically, the difference is that the engine sends the event to the master, and the reactor is listening to them, right?
So the question is, an engine sends the event to the master. Actually, use the engine. Engine can do a lot of things. It's more like you're creating an application as opposed to a reactor that is, see an event, do this thing. So, and I've used mostly reactors for most things. Okay, so on this server here, I have two minions. One's a Linux server, and the other one is this Hue bridge. So we can run different commands on here. So let's maybe the version I'm running of Salt. Get some more detailed information about the minion. So this is a Ubuntu 14.04 server. We can get information about the server itself. So see what its disk usage is. A list of all the packages and the versions they're installed. We can run one-off commands. So we have remote control over all those servers. Now, I'm going to open up run an event viewer. Okay, so as events come through, we can see those events flow by. So for example, if I restart system CTL, I'm accustomed to that now, so get these backwards. So we can see I restarted the Salt Minion, and then an event came through. Salt Minion, the salt is the name of the minion, and the event was a start. And then we get information about that. We get a timestamp, the ID of the minion, and the minion tag. So again, there's a yeah, so if I want to send in events, I can run a command for that. So I sent an event. We had 2 arguments. So there's an event because I ran a job. So this is the event that I ran a job. And then this is the actual event. So hello world is the tag that we sent. And then, yeah. So we can see the events coming through. So now we can use this for our benefit. So let me open up the iNotify. Okay, so here we have this text file that's I'm watching. If I echo something into that file, that should give us did I? Oh. This is the drawback of doing live demos, right? Okay, so we're watching /serve blah.txt. Okay. So it came in. All right. So what happened is I have some reactors set up to watch for those events. And so the event came through, we modified that file, and then some reactors happened and did some stuff on that. Again, so we have a variety of reactors. We can send events, and we can do interesting things. Now, in addition to watching your systems and taking care of that, we can also react and do things with the outside world. So let me see if I can get this lamp to work here. So here we have a hue bridge that's connected to this light. And the hue bridge has a REST API that we can interact with. And we do that over a Proxy Minion. So a Proxy Minion allows you to set up a kind of a fake minion that doesn't have the full capabilities of a minion, but that talks to some device. So this Proxy Minion connects to this hue bridge and allows us to do things, interact with it, run commands on it. So I'm going to start up the Proxy Minion. This Proxy Minion is named Huey, and we can set the color. Okay, it's working, yes. So color, we can set it to green. We can do things with this, right? So we have a WTMP beacon, that allows us to watch all events with regarding to logins. So anytime someone logs into the server, we can send an event. So that's what this means here. Any login that happens, we're going to send an event. So we have so you can see here, when we log in to this production server, we have a reactor that saw that, turned this light red, and also did a few other things. And because nobody should be logging into your production servers, so there's something wrong. So either there's a massive problem going on and you legitimately need to have someone log in and see what's going on with that server, or some sysadmin or a developer is misbehaving and should not be logged in there. So you could do other things besides turning a color, changing the color on the light. You could blare a siren. You could send a PagerDuty message. You could log something somewhere to keep track of things. There's a variety of things you can do. We also have a reactor on this that will, when I log out, then it'll come through, come back, and it's blue, so we're happy. So you can do stuff like that. Now, let's show what it looks like with the REST API. So I'm going to start up. So by default, the REST API is turned off for obvious security reasons. But I'm going to start it up here. Okay. So REST API is running, and it's configured such that only certain users can connect to it. So we have this config here, so I'm going to run this on port 8000. I've disabled SSL, don't do that in production. And I'm setting up, I have a PAM user on this box that I've allowed to do anything on the REST API. So typically you'll want to limit, right, use the least amount of permissions for a user. So just give the user exactly what you need them to do. But in this example, I'm giving demo user all rights. Now, one thing that most people don't know that Salt API can do is host a single page application, SPA. So we're going to run this HTML here, and we have a little web page that'll pop up, and we'll do some stuff in JavaScript. So let's start that up. Actually, it's already started up, so okay. So I need to log in. This is a PAM user. Okay. Now I'm logged in. Now, I have some interesting things that are happening here. So after this web page came up, it accessed the master event bus, is now watching that event bus right here in the web page. So it's streaming from the event endpoint and is watching for things. So if we do things like logging into the server, light turns red. We also see that on this web page that, hey, someone's logged in. If I log out, you see that they logged out, and the light turns blue here. So if you notice, there is a phone number on there. That phone number goes to a Twilio account that I have. And we have a beacon that monitors the Twilio text message queue for that number. So if anybody want to give it a try, go ahead. Please keep it rated G. Oh, you know what? It helps if you turn the beacon on. Oops. Oh no, it's on. Okay, is it? So here's a sanitized version of my Twilio config. Okay, yeah, it's on. So let's go here. Yeah, I think someone tried to call it. Yeah, it's not set up to do anything if you call it. Wow, this is awesome. Do we have to authenticate against? So you can see this is live. This is not a recording. Okay. Okay. It's running. So thank you for sending those. You can also send pictures, and it'll display them on here too.
That doesn't sound like a good idea at all.
Please, rated G. Rated G.
That doesn't sound like a good idea at all.
Come on, what's going on? Yeah, let me kill this minion here. I want to show an image. There we go. So some people have uploaded some pictures. Got one of Jeff playing the guitar here somewhere. So anyway, so again, what this is doing is the beacon is has some sanitizing going on there, but apparently it's not running right now.
Now we're using your beauty over to blind Bitcoin.
Another thing you can do too is if you send in a color, it'll update the background of the thing there and change the color of my light here. That wasn't me. It said red. It said red chartreuse. All right, all right. So we can see that you can do a variety of things here. And you can do a lot of things. I'm just going to turn that off. So I used to ask for a couple people to give me their cell phone numbers as a demo, and then I would actually send them texts and things. So every time I logged into the server, I'd send them a text. And the first time I did that, I actually forgot to turn it off on my laptop. So for the next 2 days, every time I logged in, every time I opened up a terminal, this guy was getting a text, and then I got a call from this Apple developer. He's like system administrator at Apple. He's like, hey, could you take me off that demo? Because I'm getting all these texts. So I just stopped doing that because, again, I just wanted to kind of show you can do a lot of crazy stuff with Salt. Whatever you're working on, your infrastructure, there's always going to be that last 15, 20% that's unique to your company, to your organization, your group, and it's really easy to add your own. Adding a new Python module to that to do something specific to you is very simple. And you can integrate Salt with almost anything that you're already running. So if you have a group that's running the latest Kubernetes clusters and various things, you can still use Salt to help manage that, as well as manage your existing MySQL server that's been running for 10 years, your existing HR applications. And Salt doesn't care where it's all hosted. It could be locally on your laptop, in your data center, on various clouds, anywhere around the world. And it's pretty amazing things that are being built with Salt. You've used systems today that use Salt. So anything that goes through Cloudflare, their systems are managed by Salt. If you use your credit card at all today, there's a really high chance your credit card company used Salt. And just like yesterday, probably a 50% chance that the processing was handled by servers that are managed by Salt. If you use an app to call a car to bring you here to SaltConf, it's a pretty good chance it's managed by Salt. If you use the Wi-Fi on the airplane flying to Salt Lake City, likely it was managed by Salt. It's being used everywhere in a whole variety of applications. So don't be afraid to poke around and do more than just configure your server. You can do a lot more. So I'd like to take a few minutes to open up for questions. So if anybody wants to. So the question is the event bus shared if you have a Syndic? And yes, the event bus gets passed up through the Syndics up to the top level Salt Master. And then the event bus, if you're using Salt Enterprise, is also passed up to your Enterprise Master as well. Yes. A Salt Master will see any event from any minions below it. If you have Reactor set up in Salt Enterprise, then Salt Enterprise can do things based off that as well.
But Syndic by default is not bidirectional, right? It's one we feed up to.
So the question is, Syndic, is it bidirectional? It works just like regular Salt. So when the master publishes a command on its pub port, the Syndic publishes that down to all its minions below it, and then all results pass up through the Syndic back up to the master. So it is bidirectional in that aspect.
If it happens on master A, it rolls up to its master. What about this master? Are you going to be aware of it?
So if you have multiple masters, in a default setup, say you have a top level master and two masters below. If you have an event down below, you will only flow up to the top level. It won't cross down. So in that situation, if you needed to have that cross passing of information, you could have a reactor on that top level that would then do something down below on the other side. So the top level master can do whatever it wants on any minion it can see. So you would then run a command to do that. Yeah.
In a Syndic scenario, where would you want to put your reaction? Do you only want to put them on master of masters or on Syndic as well?
The question is, in a Syndic scenario, where would you want to put your reactors? On a Syndic level or up at the top level? It kind of depends. So those top level masters, depending on your infrastructure going on, so sometimes it makes sense to have that happen on the lower level masters to kind of distribute the load when that happens. If you need to have reactions that react across the entire infrastructure, regardless of what Syndic the messages came from, then you need to have it at the top. So it's one of those situations where you kind of have to play with it. If your top level master is not overloaded and can handle it just fine, then it's probably the easiest place to do it because it can see everything. So if you're running 500 minions or something, yeah, that's totally fine. If you're running 100,000 minions with a variety of masters, you'll have to kind of test and see where that would make the most sense. The question is, can you filter the type of events the master of masters sees? I think we had some discussions about that. I don't know that we can. Does any Salt engineers know for sure? Yeah, I don't know 100% sure. I think all events get passed through. We filter out a few. So for example, I think we filter out like the auth events and some other things like that where there's a lot of them. Because and actually in newer versions of Salt, we added that so we could. Yeah, you can whitelist and blacklist when you log those events. I think they all go up, but we have a flag to block auth events, and there was another event that minions were pretty chatty, so we cut that down. But for the most part, yeah, all of them go through. So. what was your question? Is there a way to truncate the events? So the question is, can you like truncate, you have like a ton of minions sending events? No, they all come through to the master. So if you have 100,000 minions all sending the same event 20 times a second, be prepared for the ensuing flood of information that you're sending through. Also, the events, they truncate, I think, by default, I think it's at a megabyte of data. So we have people that are trying to send like whole 4 gigabyte files to the event system. The event system is not for tons of actual data. If you need to specify a file, stick that file somewhere and then send an event with a file path or URL or something. But yeah, do not try to send, it'll truncate at a megabyte, and you can shrink or increase that if you want, but that's gonna adversely affect your Salt master if you're sending gigabyte files through the event system. Yeah, so the question is there a way to tune your masters to handle greater loads of events and things like that? Yeah, there's actually quite a few flags you can set in the master config, both for how many processes you have running to process all those events, as well as dealing with like the zero queue queues, like high watermarks and various things like that. So that's kind of like that's a whole nother, not even talk, like a whole nother class really to dive into those. But there's a web page on our docs that goes into a lot of those in pretty good detail. And so usually you don't even have to mess with those till you get to like 5,000 servers or something, somewhere in there, depending on how beefy your master is. So I mean you're not going to be able to run 20,000 servers, manage them from like a 1 gigabyte of RAM DigitalOcean droplet. But yeah, there are a lot of flags to help deal with that. Yeah. So the question is there a way to use zero queue to filter the same event from many minions? There's not, because part of the use case is that you can tell which minion sent which message. So they're really essentially unique messages, even if there's the same message from different minions. So there's really not any filters as far as that goes. Honestly, most of you probably don't need to worry about that too much. I mean, when you're running, we're talking like you're running 30 to 80,000 minions where you're really running into these issues. So my experience, there's not a lot of companies are running more than 4,000 or 5,000 servers at a time. So if you're under that, the default configs will almost work perfectly fine for you, even at those loads. Is anybody running more than 5,000 servers you're managing? So you got 2. So you got 2 out of the room here. So 3. Okay. Some shy people. It's okay. We're not going to track you down. Sales guys, this right there. These 2 and those 2. But you basically, until you get to really high levels, unless you're like LinkedIn or something, don't worry about most of those settings. So, any other questions before we end? Okay, I'll be around for a little bit. I did wake up with a sore throat this morning, so I apologize if I don't shake your hand because I don't want to get anybody sick. I don't know if I am sick or not, but anyway, okay, thank you.